Make x the subject of y. Okay, so what we need to do here, guys, is to get rid of the square root, and the opposite of square rooting is squaring both sides. So what I'm trying to say here is that we're now going to have y squared equals x plus 1 over x minus 4. Okay, now at this stage we want to always clear the fraction, yeah, because when you have a fraction it makes it a bit more complicated. So to clear x minus 4, we need to multiply x minus 4 across, and this means we're now going to get y squared times x minus 4 wrapped in a bracket equals the right side, x plus 1. Now let's go ahead and expand this. So we're going to now get y squared times x is xy squared minus 4y squared equals x plus 1. Now, because you want to make x subject, we want to move all the x terms on one side and the non-x terms on the other. So for instance, we're going to move this x to the left, and we're going to move minus 4y squared to the right. So to do that, we're going to add 4y squared and minus x. So we're going to have something like xy squared take away x equals 1 plus 4y squared. Okay. So now we need to isolate x, and to do that, guys, we need to factorize x out, and we're left with y squared minus 1 equals 1 plus 4y squared. And then to get x a subject, just divide y squared minus 1 across, and you're left with x equals 1 plus 4y squared all over y squared minus 1. And you're done. 17. Prove that the difference between two consecutive square numbers is always an odd number. Show clear algebraic working. Okay, when they say two consecutive square numbers, that means one square number after another. An example of this, guys, is like 2 squared and then 3 squared. And then you want to find the difference between them. So like 3 squared minus 2 squared. Okay. Now, because you want to do it in algebraic terms, you just go write this in terms of n or x or something. So let's say, okay, let's treat 3 as n, yeah? So we can say we have n squared, because that's your common square number, and you want to minus it by a term before it. So before n squared, we're going to have n minus 1, yeah? So it's always going down in ones, because the difference between 3 and 2 is 1. And all you have to do now, guys, is literally expand this and then just simplify it, literally. So expanding this carefully, we're going to now have n squared minus, so n minus 1 squared, that's just literally n minus 1 times n minus 1, okay? So over here, so you're going to multiply this out carefully. You got n times n. So what I'll do, I'll just put a little bracket here, guys, because you got a negative before it. You're going to get n squared, and then n times minus 1 is minus n, and then minus 1 times n is another minus n, and then you're going to get plus 1. And then simplifying this quickly, minus n take away n is going to give us minus 2n. So that all becomes n squared minus 2n plus 1. Now at this stage, you're going to have to expand this again. We're going to now have, therefore, n squared take away. And because you got a minus sign before the bracket, flip all the signs, yeah? So you're going to get minus n squared plus 2n minus 1. And then cancelling like terms, n squared take away n squared is 0. You're just left with 2n minus 1. And that's it, guys. And to show that this is an odd term, well, odd terms are always 2n minus 1. An even term is always 2n. Okay, so these are the two things to spot. If you got 2n minus 1, then you've got it. This is clearly an odd term. And we're done. Alright, 18. The histogram gives information about the times in minutes that some customers spend in a supermarket. Okay, so on the x-axis, we've got the time spent in minutes, and on the y-axis, we've got the frequency density. And if you look at each of these blocks, this is the number of customers. So once you work out the area, then we know how many each customer spent under a certain time period. Now, for part A, they want us to work out an estimate for the proportion of these customers, so in other words, a fraction, who spent between 17 and 35 minutes. Now, before we actually solve this question, let's go ahead and work out the areas of each of these blocks, so we can find out how many customers were in each time period, yeah? So for the first block, for example, we can see that the width here is 10, and the height here is, about 0.7, yeah? So we can say that the area of the block, which is just like a rectangle, so 10 times 0.7 is just 7. For the next one, we can see that the width is 5 and the height is what? 3.4, yeah? So let's put 3.4 height. This means that 5 times 3.4 is going to give us 17. So that's the area of this block. And then the next block, I think the width is, it's a bit sneaky. So it goes up to 24. So it's between 15 and 24. So the width is 9. So it'll be 9 times 1, which is 9. For the next one, guys, we've got a width of 6 times 2.5. That should give us 15. Okay, so just use your calculators, yeah? And for the last one, so we got a width from 30 all the way to 45, yeah? So this is 15 times 4.8. And 15 times 4.8, and I'm just doing that now, gives us 72. Okay, so now looking at all these figures, yeah? So I'm just going to delete that right now. We can see that the total frequency, yeah? So the area of all the blocks, if you add them all up, should give us a total of 120 customers, yeah? So that's how many people are here. So going back to the question, they want us to find the proportion of customers that spend between 17 and 35 minutes. Okay, so we just need to find out where 17 is and where 35 is. So just delete these numbers for a second, guys. Well, we can see that 17 is somewhere over here, yeah? So it's actually close to 20, and we know that 35 is actually here. So this long line going up. So this long bar here. Okay, so just doing it carefully. Okay, and now all you want to do is essentially find the areas of each of these blocks now. Well, we did this block earlier and we got 15 over here. And now for this block here, it's now a width of what? From 17 to 24. That has a width of 7. So just put a width of 7 and has a height of 1. 1 times 7 is 7. And for the last block, the width is 5. 30 to 35 is 5. And the height is 4.8. So it's going to be 5 times 4.8. And that gives us 24. And now finally, guys, all you do is literally add these numbers up. So 7 plus 15 plus 24, that should give us an answer of 46. So therefore the proportion is going to be 46 out of the total number, which is 120. And that's it for A. Now for B, one of the customers is selected at random. Given that this customer has spent more than 30 minutes in the supermarket, so what they're trying to say here is that this customer spent some time in this block, so it's one of these 72. Find the probability that this same customer, so out of 72, spent more than 36 minutes. So because we know it's in that block, we know immediately that the probability is going to be out of 72, yeah? Now, let's find the area which covers more than 36. So more than 36 implies that, well, 36 is over here. We're trying to find this block going all the way up on the right hand side, yeah? So all of this block on the right. So looking at this, we know it's between 36 and 45. We know the difference between these two has a width of 9, and we know the height is 4.8. So essentially it's just 9 times 4.8, and wherever that area is, so 9 times 4.8, sorry, we then divide it over 72. And when you guys do this, you should get a probability of 0.6. And that's it, guys. That's B done. All right, 19A. Write down an equation of a line that is parallel to the line with this equation. Okay, every time you get a straight line equation, guys, always think of y equals mx plus c. Okay, and in this case, m is always the gradient and c is always the y-intercept. Now, when you have parallel lines, all that literally means is that the lines are going in the same direction. In other words, the gradient is the same. Okay, now to get the same gradient, and if you look at this equation, let's rewrite this in that form, yeah? So we're going to have y equals minus 4x plus 7. So same gradient means m value is the same. Check. So we're going to have y equals minus 4x. And now all you need is a different y-intercept, yeah? So for example, we can say plus 2 or even minus 3 or anything is good. So this is just one example. Now for the next bit, it says that the line L passes through the points with coordinates minus 3, 1 and 2, minus 2, okay? Find an equation of the line that is perpendicular to L. So again, like parallel meant same gradient, perpendicular means the gradient has been flipped, yeah? Has a negative reciprocal. We're going to get to that. And passes through the points with coordinates minus 6, 4. Give your answer in this form. Okay, so essentially we're dealing with straight line equations. So always think again of y equals mx plus c. Now the first thing you want to find out is the gradient, yeah? Every time we get 2 points, we can easily calculate the gradient. Well, the gradient in this case of the line L is going to be the change in y over the change in x coordinates. So all you do is look at your y coordinates. So we got -2 and 1, subtract them. So -2 take away 1. And again, subtract the x, it will be 2 take away -3. So 2 minus bracket -3. And then when you put this in a calculator, you should get -3/5. Now, this is the gradient of the line L. Yeah? So for the perpendicular line, we need to flip this gradient. So we say, okay, the new gradient, let's call it MP, yeah, perpendicular, is going to be, well, you flip the sign, so it'll be a positive, and then you flip this upside down, so it'll be 5/3, okay? And that's it. So what that essentially means is that for the new line, we now have an equation which is y equals, instead of mx, is going to be 5/3x, and then plus c. So now we're almost done. Now it also tells us that this particular line passes through this point, -6 and 4. So let's go ahead and pop this in, yeah? Let's replace the x value of -6 and the y value of 4. So we say at -6, 4, we're now going to get 4 equals 5/3 times -6 plus c. So literally you just got to solve for c. So expanding this one and solving for c, you're going to get 4 equals, well, 5 times -6 is -30/3, and then you got plus c. And then just doing a quick maths, just plus this to the other side. So in your calculator, you're going to write 4 plus -30/3, and you're going to get a c value of, well, I'll do it here, 14. So all that tells us now is that your c value over here is 14. So our equation gets updated to y equals 5/3x, so 5/3x plus 14. And usually this would be it. You actually found your equation. But what they want, guys, is to rewrite this equation in that kind of form, yeah? Where a, b, c are integers. In other words, no fractions, and you got to start with x, y, and a constant, and it has to equal 0. So all you got to do is firstly clear the fraction, and what I'll do is times this by 3. So you're going to get something like 3y equals 5x, and 14 times 3 is 42. And then rearrange it so you have everything equal to 0. So I'm going to minus 3y in. So you're going to get 5x minus 3y plus 42, and then all of that now equals 0. And you're done. Alright, 20. So the area of a rectangle is 18 centimeters squared. The length of one of its sides is √7 plus 1 centimeters. Okay, so you got SIRS here. Without using a calculator and showing each stage of your working, find the width of that rectangle. Okay, so you got a rectangle problem. So what I would recommend, guys, is firstly sketch the rectangle, yeah? So draw something like this. Label one of its lengths, so the length was √7 plus 1, so that goes here, √7 plus 1. And we know the area of this rectangle is 18, so write 18 inside. And they want us to find the width, so let's call that W. Now, to find the width, again, we got all the information, so all we do is just calculate it, literally write an expression for the area of a rectangle. Well, the area of a rectangle is just the base times the width times the length. So it's just going to be W times √7 plus 1, and it's going to give you an area of 18. And to find W, just make W the subject. So dividing √7 plus 1 across, you can get W equals 18 over √7 plus 1. Now this is the part where it seems a bit weird now, because now they want us to give your answer in this particular form. And actually, if we look at it carefully, it looks to me like there's no fraction. So what they did, they've rationalized it. So this is kind of a secret rationalizing question. And well, to fix this up, and you can't use a calculator, we got to somehow deal with the fraction below, yeah? And what I recommend, guys, is that when you have SIRS, you're always going to times up and down by its opposite. So instead of √7 plus 1, you can times up and down by √7 minus 1, yeah? What happens here is that it actually cancels out the bottom. Now doing this, and always put a bracket around these guys, let's go ahead and just expand it out now. So on the next line, you're going to have 18 times the top half. It's just going to be, well, just keep it as 18 bracket √7 minus 1 for now, yeah? And on the bottom line, you're going to have √7 times √7, which is a whole 7. You're going to have √7 times minus 1, which is minus √7. So this is kind of like a double bracket problem, yeah? Just expand it term by term. And again, 1 times √7 is plus √7. And the last one, 1 times minus 1 is minus 1. So now you guys could just use a calculator and get the result at the bottom. If you just put in a calculator, you're just going to get 18 root 7 minus 1, and on the bottom you're going to get 6. And then you can see that 18 over 6 cancel out, and you're just going to get 3. Well, 3 bracket root 7 minus 1. And now guys, I recommend you expand it. So now you're going to get 3 root 7 take away 3. And yeah, we're done. And we got the form they want. You got a constant, you got a number, square root of number, and another number. And yeah, that's it. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications. And if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.